All right, good morning. Today we are going to talk about equations. So like an equation and how to solve something when you have fractional exponents. And so we've already talked about these, but just remember the cubed root is the same thing as 5 to the third. 4 to the 1/4 is the same thing as the fourth root. 3 to the 1/5 is the same thing as the fifth root of 3. So remember, the bottom part of the fraction, that always is your index of your radical. Okay, so we spent today on fractional exponents on purpose. So here's another example. If you have x to the 3/5, that is the same thing as x to the third, the fifth root. Or notice these are the same. You could do the fifth root of x and then raise it to the third. So which one do you do? It kind of depends on which way would be easier depending on the problem. So it really just depends. And then one thing to keep in mind is that not every radical will have numbers that work. So if you have an even root, this one's odd, but say this was a 2, 4, or 6, the radicand must be positive. You cannot have an even index and a negative radicand. And so that's all review from a previous day. So how do you solve equations with fractional exponents? You isolate the variable that has a fractional exponent. So like this one is isolated. This one is almost isolated. I need to get rid of the 10 and I need to get rid of the 2. Then you're going to convert your fractional exponent to a radical and then solve for the variable by using roots and or exponents. There's actually kind of two ways you could do this. You don't technically have to convert on step 2, convert to a radical. So I'll show you two different ways to think about it. I'll show first the way they're showing. The variable is isolated. So what they're saying is you could write this as the fifth root of x to the third is equal to 27, because this is your index, and then raise into the exponent. And it's your choice if you want to raise to the exponent and then do the radical, or do the radical, then do the exponent. From there, to undo the third power, you cube root both sides. And then the cube root cancels out the third power. So we're left with just 5 index x equals the cube root of 27. 3 times 3 times 3 is 27. So that would be 3. You then get rid of your fifth root by raising both sides to the fifth. And we get x is 3 times 3 times 3 times 3 times 3. I hope I said 3 5 times. That's 3 to the fifth, 243. Yes, I used a calculator. Now, checking my work. If I take 243 raised to the 3/5, I should get 27, and I do. So it's not a bad idea to check your work. Another way you could have done it, which is usually the way I do it, so I'm going to show you two ways. So we're starting with x to the 3/5 equals 27. So what you could do is you could do both steps at once. You could raise this to the 5/3 and raise this to the 5/3, the reciprocal. So this is like doing 2 steps in one. But then you get x. This becomes 15/15, which is 1, which is x to the 1. And then we have 27 to the 5/3. I would take the cubed root of 27 first, and then raise to the 5th power. Cubed root of 27 is 3. And 3 to the 5th is 243. So 2 different ways. I kind of like this step because you could do 2 steps in once. All right, this one, the only thing that makes it different is the x to the 5/4 is not isolated. So we take away 10 from both sides. We get 2x to the 5/4 is equal to 64. We divide both sides by 2. We get x to the 5/4 is 32. So I need to get the variable isolated. That's the first step. And then from there, you could do this in 2 steps. I like to do it in one. I'm going to raise this to the 4/5 and that to the 4/5. Five-fourths and 4/5 cancel, and I get x is equal to, and I could change this to the 5th root of 32. And then after that, raise that to the 4th. 5th root of 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 5th root of 32 is 2. And then 2 times 2 is 4, times 2 is 8, times 2 is 16. So I get x is 16. Check your answer. We got 2 times 16 raised to the 5/4. So 2 times 16 raised to the 5/4 plus 10. That should be 74. Come on, let's show me. 74. You can also check your answer on Desmos. If you type in this into 1y equals, and then you put y equals 74, they should intersect at 16. All right, example 2. We have x squared is 16. This is not a fractional exponent. This is quick review. So when you're solving here, remember, whenever you take the square root, you have to do the positive and the negative. Okay, so like in this problem, we have to the 2nd power. So when we take the square root, we're going to have to do the positive and the negative. Okay, because if you plug in 4 squared is 16, and so it's negative 4. Negative 4 squared is 16. So x to the 2/3 is 16. And this might be one where it's better to do the cube root and then square, but I'm just going to stay consistent. I'm going to raise both of these. I don't have much room here. I'm going to rewrite it. I'm going to raise both sides to the 3/2. Now this is technically like taking a square root. This is probably why they suggest doing this in 2 steps, because it's easy to miss that. So maybe we will do that in 2 steps. Let me try again. So starting over, this is the same thing as the cubed root of x squared. Okay, the exponent, the index, and that's equal to 16. We're then going to undo the square by doing the square root of both sides. But anytime you do the square root or fourth root or sixth root, you do positive and negative. So the square root cancels out the square. I'm left with the cubed root of x is equal to the 16. Square root of 16 is 4. Positive and negative 4. I will then take the cubed root of x and raise it to the third. And I get x 4 to the third. 4 times 4 times 4, 64. Yep, 64. Negative 4 to the third, that'd be negative 64. All right, well, let's see if they both work. So remember, when taking the square root of both sides of an equation, there is a positive root and a negative root. This is because solving an equation such as x squared equals 16 by extracting roots must produce the same answer as if we had solved by factoring. So remember when we had x squared equals 16, and then we moved the 16 over, and this was difference of two squares. We got negative 4, actually 4, negative 4. We learned how to factor that before. So it's kind of the same thing. Oh, that's what I was doing. I was checking my work. I think one answer is 64 to the 2/3. $16, yes. I also think another answer is negative 64. And notice I put that in parentheses. And I put the 2/3 in parentheses. And I also got 16. So this one has two solutions. They both work. Oh, I'm on here. Huh?
I'm gonna be in a parent meeting, so I'm gonna miss the first school.
Sorry about that. Someone walked in. If I go to desmos.com and I type this in, x to the 2/3. I guess technically I don't need parentheses. And then the other one's y equals 16. I have to type y equals. And I go up here to see where they cross. They cross over here at negative 64. And they cross over here at positive 64. So those are my two solutions. That's another way you could check your work. For some reason on Desmos, if I just put 16, it doesn't work. You have to put y equals. Okay. All right, here, x squared equals negative 25. If I were to solve that, I would get, I have x squared equals negative 25, and I solve that, and I take the square root of both sides. You cannot take the square root of a negative number. So this one will be no real solution. It has a solution, but it's imaginary. It's complex. And we talked about complex, but we're not going to do it in this unit. Okay, so you cannot have a negative number and take the square root of it. So a problem like this, we have x squared. Well, you're going to have to take the square root to undo x squared. And so as soon as you take the square root of negative 25, there's no solution. So on this one, there is no solution. And I'll show you real fast. So this would be the cube root of x squared. It's negative 25. I would then square root both sides to get rid of the square. And as soon as I square root, you cannot take the square root of a negative number. So this would be no real solution. I wonder what that looks like visually. X to the 2/3 negative 25. Oh, y equals negative 25. Oh, on a different line. So you see, when is this going to ever intersect this? It's just not going to happen. It's not possible. This goes up indefinitely. This goes up indefinitely. There's no way that these two are going to intersect. So no real solution. Here, square root of something equaling a negative number, no real solution. Here, let's see what we get. So I have x to the 3/2 is negative 64. I can write this in many different ways. Let's do x to the 3rd square root. Actually, it's usually easier to do this way. X to the 3rd. I thought about cubing and then square rooting, but it's easier to cube root. It's easier to make something smaller than bigger. To undo the 3rd, I do the cube root on both sides. When you do the cube root, you don't have to do positive and negative. That's only when you have an even root. Cube root of negative 64 is negative 4. Yeah, negative 4 times negative 4 times negative 4. The cube cancels out the 3rd power. I'm left with the square root of x. I already see a problem. You cannot take the square root of a number and get back a negative number. There's no way. So this is, again, no solution. No real solution, I should say. So when you're dealing with fractional exponents, there's many numbers that will make it have no solution. So it is not imperative that we check our answers like we do with radicals, but I would always do it anyway, just in case you didn't see something. So this is more like what you'll see. Okay, this is more on what we're trying to do. So notice the radical is by itself, or I should say the exponent is by itself. I cannot add 3. I cannot divide by 2 because they are grouped together to the 9/7. So I'm going to rewrite this. I'm going to write this as the 7th root raised to the 9th. And like I said, I think it's easier to put this as the 9th root 7. So that's how I want to do it. So you could write this as the 7th root of 2x minus 3 raised to the 9th. Or we could raise it to the 9th and then take the 7th root. All right, so to undo to the 9th power, I am going to take the 9th root. Of both sides. What is the 9th root of -1? It's actually -1. You take -1 times itself 9 times, you get -1 back. So the 9th root of -1, that's -1. The 9's cancel. And now I have the 7th root of 2x minus 3 equals -1. From there, undo the 7th root by taking both sides to the 7th. The 7's cancel. I'm left with 2x minus 3. And if you take -1 times -1 times -1 7 times, you get -1. From there, I'm down to an algebra 1 problem. I add 3 to both sides. Divide both sides by 2, and I get the answer is 1. Check my work either using Desmos or a calculator. 2 times 1 minus 3 to the 9/7. 9/7 must be in parentheses, and I'm hoping for -1. I would almost encourage you that you use Desmos to check your work, because Desmos will help you find an answer that you didn't see the first time. 5A. Yep, x equal 1. All right, let's do this one. Ooh, that one looks weird. So I get the fractional exponent by itself. I add 5 to both sides. I get x over 4 to the 2/3 equals, if I add 5 to both sides, that's 25. Huh. Okay. And now I'm going to write this as the cube root of x over 4 raised to the 2nd. So the 3 is your index, the 2 is your exponent. To undo the 2nd power, I'm going to take the square root. Anytime you take the square root, you look at the positive and the negative. So the square root cancels out the square, and I'm left with the cube root of x over 4 is equal to positive and minus 5. I almost need more paper. Now I have 2 equations. Let me think. So now I have 2 things to solve. So I would write this probably as 2 equations at this point. I'd have cube root of x over 4 equals 5. And then I would also have the cube root of x over 4 equal -5. Raise both of them to the 3rd power. And I get x over 4. The 3's cancel. And -5 to the 3rd power I should know that. -125. Yeah, -125. Here, same thing, raise both sides to the third power. And I get x over 4 equal to positive 125. From here, I'd multiply both sides by 4. Cancel out the 4. And I get x. The negative 125 times 4 is negative 1,000. And then here, multiplying by 4. Oops, going crazy today. 4 cancels. I get x is 1,000. I get positive and negative 1,000 is where they intersect. I'm going to go graph this and check. Yes, thank you. I can't multiply. Negative 125 times 4 would be negative 500. And that would be 500. Thank you. So on Desmos, we had, just get rid of these. We had x divided by 4 raised to the 2/3 minus 5. That's different looking. And then we had y equals 20. So trying to see where these intersect. Looks like it's going to be around 500. And see, on my last problem, before one of you fixed me, I had said 1,000, and then I would go back and look and go, wait a minute, where'd I mess up? Now the other one you could guess is going to be negative 500. There we go. Negative 500. Okay. All right, I probably have time for just one more. In your notes, I want you to see that here, a problem like this, it's not possible to take any real number, square it, and get a negative number in return. There's no way to take something, square it, and get a negative number. So this would be no real solution. And then for this one, this is x to the negative 3/5. That's confusing. But remember, we learned that negative exponents you could bring down to the denominator. And 0.001 is the same thing as 1 over 1,000. And then you can just cross multiply. And then when you solve, you take the cubed root of both sides. It looks like they wrote it down. Cubed root of both sides, that's 10. And then raise both sides to the 5th, and you get 100,000. So negative exponents, remember, you can bring those down and make them positive. So like C would be a good one to do. It's a negative exponent. First thing I would do is divide both sides by negative 8. From there, negative exponent, bring it down to the denominator. When you have a fraction and the numerators are equal, the denominators must also be equal. So I just found that x to the 3/2 has to equal negative 8. from there, I can rewrite this as, I always have to think, square root of x raised to the third. And then I'm going to cube root, or cube root both sides. Cancel out the third power. The 3's cancel, leaving just square root of x. And the cube root of -8 is -2. Wait a minute. You can't square root something and get back a negative number. There's no way. So this one is no real solution. No solution. Let me go double check. Desmos. So we had -8x to the -3/2 y = 1. Oh, I zoomed way out. I forgot about that. There is a way to reset that. I just can't remember. So when is the green line gonna touch the blue line? Never will. The blue line, this is called a, oh, you click the house on the side. Okay. Yeah, to reset, you hit the house on the side. It was covered up with the videos. Okay. Yeah, so this is called a horizontal asymptote. The blue line is never going to get to 0. It's never going to pass it. So these are never going to have a solution. All right, other than that, that's all I have. Have a good day.
Are you all virtual this hour? Okay, thanks.
Bye-bye.